take a look at page 157. All right. So, again, what I mentioned before, the one thing that we are looking at doing, okay, if at all possible, is to factor the equations. That's the easiest method in which you can solve for roots or x-intercepts or zeros. Okay, so they start you off. 157 is just factoring, but this one has a unique characteristic about it. If I ask you to factor that, how does that look in factored form? What's the first thing? Let's go back to the very beginning of factoring. What's the very first thing that I always look for? Well, as it turns out, yes. But no, what's the first thing I got to do? It's the very first thing. I asked you this exact same question Thursday or Friday last week. No. What's the first thing you look for? Okay, this isn't making sense to you, right? So, don't mumble. Be louder.
What?
Yes. Okay? Doesn't matter if you're wrong. Throw it out there. Okay, both of these have the same unique property about them. We'll start with the bottom equation because this is the one point I'm trying to get at. What's the first thing I got to look for here? What am I looking for? For me? Sure, but it could be a variable too. So it doesn't have to be coefficient. What am I looking for? When I factor, I am always looking for the greatest common factor to begin with. And if you can take out the greatest common factor, it simplifies the equation quite a bit. All right? So what's the greatest common factor here between 8 and 18? 2. So let's take that 2 out. That leaves me with 4a squared minus 9b squared. What do you notice about what's in the brackets?
Perfect squares.
Perfect squares. With what between them? Pardon me? Ow! A negative. Subtract sign. Right? Okay, so it's a subtract sign. What is that called?
A difference of squares.
Excellent. Excellent. So, the difference of squares, a squared minus b squared, right? 2. 2a minus 3b times 2a plus 3b. That's the bad boy that you have to, at all times, have to look for. So, going back to the first question, what do you notice? Perfect squares with what between them? A subtract sign. Right? What is this? Square rooted? X over 4 minus y over 5 times x over 4 plus y over 5. Difference of squares. This is the guy that you have to watch out for at all times. If you run into an issue where you can't factor something, that's probably the next thing you want to look for after a greatest common factor. Is it perfect square? Subtract perfect square. Because if it is, then it's easy, right? Okay. Example. I'm just going to give you one more here. Here's one. This is a more complicated example. Okay, now we spent quite a bit of time in grade 10. Bless you. We spent oodles of time in grade 11 applied factoring equations. All right? So this guy, I need to factor it. Right now, it's a little sloppy the way it looks. So what I'm going to do then is I'm going to rewrite this. Instead of x plus 3, I'm just going to put c squared plus 8c minus 5. Okay, what's the very first thing I should be looking for? Greatest common factor. Do I have a greatest common factor in here? No, I don't. So I can't do that. All right, so I have to factor this. So, what do I have to do? Well, because I have an A value, I want to use the product of A times C, okay, which is 4 times -5. The sum has to equal plus 8. What are the factors of -20? What are the factors of -20 that add to give me plus 8? Plus 10 minus 2. Okay? So now, instead of writing 8C, I'm going to use these two guys and then group them. So I get 4C squared minus 2C plus 10C minus 5. Okay? Again, done this before, right? At that point, I put brackets. What am I looking for now? Greatest common factor. What's the greatest common factor in the first bracket? 2C. Let's take it out. Leaves me in 2C minus 1 plus. What's the greatest common factor in the second bracket? 5 is. Take it out. 2C minus 1. Right so far? Okay, excellent. What's the greatest common factor of these two terms? 2C minus 1. And when I take it out of here, what am I left with? 2C plus 5. Okay? But I'm not done because what was C actually? X plus 3. So I have to put that in here. And then I would simplify it from there. Okay, so I would multiply my 2's through. So I'm going to get 2x plus 6 minus 1. 2x plus 6. Oops. Quick. Bracket. Add 5. Two x plus 5. 2x plus 11. That.
There's like some ones and two thumbs.
All right. Okay, let's get back to more what we're used to. Go to page 158, please. So again, if I were to write this as an equation for a graph, I would have the y there instead of the 0. But what I'm trying to do is actually find out what. I'm trying to find out what my roots are. And where do my roots occur? When y is equal to 0. They're the x-intercepts, right? So now, I need to factor this in order to get my x-intercepts, my roots, my zeros. So in this one, there is no greatest common factor, correct? There's also no, the a value is 1. So what do I do? What's the factors of x squared? X. What are the factors of negative 24 that add to give you plus 2?
Negative 1, 6.
Negative 4 plus 6. Right? What does x equal? There's your two reals.
Mhm.
If x is 4, 4 subtract 4 is 0. 0 times this is 0. Negative 6 makes that 0. 0 times that. Again, what we're trying to establish or get to is what we call the zero product rule, which says that if I take one number and I times it by another number, in order to get 0, either A or B has to equal 0. So either this or this has to equal 0. So what number is going to make that equal to 0? 4 is. What's going to make that equal to 0? Negative 6 is. Okay? All right, the next one. All right, is there a greatest common factor here? No. So I have to use my method that I used here. Product, sum, factors. Product, 6 times negative 35. Sorry?
Negative 20.
Negative 210? Yeah. Sum is negative 11. And the factors are pretty straightforward now. What are the factors of 210 that are going to add to give you negative 11? Quick, quick, quick.
Negative 21 times 10.
Well done. Negative 21 times 10. So, I write those in instead. 6x squared minus 21x plus 10x minus 35 equals 0. Brackets. And then greatest common factors again. Greatest common factor here, 3x gives me 2x minus 7 plus, take a 5 out of here, 2x minus 7, 0. What's the greatest common factor between this and this?
27.
Take the 2x minus 7 out, and I'm left with 3x plus 5 equals 0. X is equal to, add 7, divide by 2, subtract 5, divide by 3. I'm doing it quick, I'm making it look easy. But my expectations are that you should not have issues with this. Okay? Again, our goal is to solve right? So I'm asking you to factor, okay, or solve these questions. So the only way we can do a quadratic equation and solve it is if we get it equal to 0. Because our whole goal is to find the zeros of the function, the x-intercepts. Alright? What are the factors of x squared? What are the factors of 16 that would add to give me negative 10?
Negative 8 and negative 2.
Good job. Okay?